This is standard 8GB6. We're going to explain a proof of the Pythagorean theorem and its converse using the area of squares. Now, first off, we need to know, what is Pythagorean theorem? Pythagorean theorem deals with finding the side lengths in a right triangle. So if we're looking at a right triangle, like right here, okay, let's get some pens, we can use it. If we're looking at our right triangle here, if your right angle is here, across from the right angle is what we call the hypotenuse. Okay, that's your hypotenuse. That's the longest side on any right triangle. The other two sides are not your hypotenuse, they're called legs. So if we're doing Pythagorean theorem, which says a squared plus b squared is equal to c squared, c is the hypotenuse. It's across from the right angle. It doesn't matter which sides A and B go on so long as they're not the hypotenuse. This is what we're going to be showing you, is that how this works, how we know this works. Now let's take this triangle and let's draw boxes. Let's draw squares here. If the side length here is 3, then to draw a square, it's going to be 3 by 3. This side is A. So if I'm looking for the area of this square, that would be A times A. That's your area, which is A squared, right? Isn't that what we're talking about right here? In this case, this side length is 3. That's 3 times 3, which would give you 3 squared, which would give you 9. The area of this is 9. Count your squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9. So if we're doing Pythagorean theorem, a squared plus b squared is equal to c squared. What we've got here is our a squared is 3 squared, which is 9. Now let's try b. Let's look at the b. This side on b is 4 units long. 1, 2, 3, 4. A square here means you've got the side lengths the same. 4 by 4. So the area on your b would be b times b, which is b squared. And in this case, that would be 4 by 4, which is 4 squared, or 16. Okay, our b squared was 4 squared, that is 16. Okay, so this is 16. Let's count our box to see if the area of that's right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes. So if I have the area of this square plus the area of that square, that's what I've done here, 9 plus 16. Let's see if it gives us the area of this square, the hypotenuse. This side shows to be 1, 2, 3, 4, 5 units long. So if I do a square that's 5 by 5, that would be, the area would be c times c, which is c squared. That's 5 times 5, which is 5 squared, or 25. Let's see, is there 25 blocks here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So what this tells me is if I make a square out of each side length and add up the squares, the square of this one is 9. The area of this one is 16. The area of this square is 25. 9 plus 16 is 25. When you have a right triangle, the sum of the squares of each side will give you the square of the hypotenuse. We drew the square on each side. What do you notice about the areas of these squares? Well, if I add up the square of the two short sides, it gives me the square of the hypotenuse. Add up the two squares of the two short sides, it would give us the square of the hypotenuse. 9 plus 16 is equal to 25. That's how we know that Pythagorean theorem works. Now, what if we need to use Pythagorean theorem to find a side length in a right triangle? If I've got a right triangle, This side's A, that side's B. The hypotenuse is going to be across from the right angle. Doesn't matter which one's A and B, but the hypotenuse is always across from the right angle. What if I were to work a problem just like this? How could I find this hypotenuse? I know A squared plus B squared is equal to C squared. Let's plug these in. C is going to be the X because it's across from the right angle. So I'm going to substitute X for C. It doesn't matter here which one's A or B. The C is the only one that matters. So the A is 6 squared. I'm going to substitute 6 in for the A. The B is 8, and we're going to square that. We're substituting that in place of the B. 6 squared is 36. 8 squared is 64. Okay, now we're trying to find the hypotenuse. If I add these two together, I have 100 is equal to X squared, but I'm not looking for X squared. I'm looking for X. How do I get from X squared to X? The opposite of squaring something is to take the square root. So what we do to one side, we must do to the other. X then is the square root of 100, which is 10. This side is 10. That makes sense because the side across from the right angle is always going to be bigger than the other two sides. And we found it using Pythagorean theorem. If you have a right triangle, you can find side lengths using Pythagorean theorem. Now they talk about the converse of Pythagorean theorem. That simply means, what if you're looking for a side that's not the hypotenuse? What if you're looking for one of the legs? When you're looking at a triangle, a right triangle, these two sides are called legs. This is the hypotenuse across from the right angle. So let's set up Pythagorean theorem. A squared plus B squared equals C squared, because we know we can find a side length in a right triangle using Pythagorean theorem. C is always across from the right angle, so our C is going to be this 13 feet. Let's substitute 13 in place of C. So we're going to substitute it in. That's C squared. Now, it doesn't matter now which one is A or B. C is the only one that matters. It's the one across from the right angle. It's the hypotenuse. Doesn't matter which side here's A and which one's B. I'm going to say A here is going to be your 5. B here is going to be your Y. So in place of the A, I'm going to put in 5. I'm going to substitute it in. In place of the B, I'm going to substitute in the Y. 5 squared is 25. Plus Y squared is equal to, and 13 squared is 169. We're going to subtract the 25 from each side. And Y squared is going to be 169 minus 25. If you subtract that, 9 minus 5 is 4. 16 minus 2 is 14. Y squared is equal to 144, but I don't want Y squared, I want Y. The opposite of squaring something is to take the square root. What I do to one side of the equal sign, I do to the other. The square root of Y squared is just Y. So Y is equal to the square root of 144, which is 12. The length of this side is 12. Does that make sense? We know the longest side is the hypotenuse. It's always across from the right angle. It's 13. These two are both smaller than 13, so that could make sense. Now, let's answer this question here. Again, dealing with the converse of the Pythagorean theorem. If the sides of a triangle are 8 inches, 10 inches, and 12 inches, is the triangle a right triangle? Well, we know if it's a right triangle. Let's look at this. Let's sketch it out. If it's a right triangle, and you got your right angle there, the hypotenuse would be the longest side. That would be your 12. 8 and 10 go on one of these sides. Let's see if this is a right triangle. We can do this by plugging it into Pythagorean theorem and see if it makes the equation true. Okay, the C will be across from the right angle because it's the hypotenuse, the longest side. We would substitute 12 in for C. The A, it doesn't matter which one's A and which one is B, so long as the C is across from the right angle. Okay, in place of the A, I could substitute 8. In place of the B, I could substitute 10. 8 squared is 64. 10 squared is 100. Is equal to 12 squared. That's 144. Okay, let's see. 100 plus 64 is 164. Is 164 equal to 144? No, it's not. So this is not a right triangle, okay? This would not be a right angle. This would not be a right triangle. And now we've gone over the proof of the Pythagorean theorem and its converse using the area of squares.